Hello friends, in the last video we have seen the definition of similarity of two polygons, and applying that definition we have solved the first exercise. Now we are going to prove the very important theorem from our syllabus, which is called as basic proportionality theorem. Already we know that the theorems are nothing but formulas for us. So many times this theorem is asked in the examination. So try to understand what is the statement of this basic proportionality theorem. So if a line is drawn parallel to one side of a triangle, then it divides the other two sides in the same ratio. So here we have considered one triangle ABC. In this triangle ABC, so we have drawn a line DE parallel to BC, isn't it? So if a line is drawn parallel to one side of a triangle, then we have to prove that it divides other two sides in the equal ratio. Means what we have to prove? AD upon DB will be equals to AE upon EC. Means this ratio AD upon DB will be equals to this ratio AE upon AC. So let us try to prove this result. So first write down the given condition. So what is given condition here? It is given to us that in this triangle ABC, one line is drawn parallel to one side of a triangle. So line DE is parallel to side BC, intersecting sides AB and AC at points D and E respectively. Now what we have to prove using this given condition? We have to prove that this line divides the other two sides in equal ratio. It divides first side in which two part? AD and DB. We have to prove that the ratio of these two parts will be equals to AE upon EC. So again, what is the statement? One line is there which is drawn parallel to one side of a triangle. Then we have to prove that it divides other two sides in equal ratio. Now to prove this result, we are using the formula to find out area of triangle. What is the formula to find out area of triangle? Half base into height. Applying that formula or using that formula, we will try to prove it. But in case of obtuse angle triangle, see, in case of acute angle triangle, this altitude means what? Height is nothing but a perpendicular drawn from vertex on its opposite side. So if you are considering this as base, this will be its altitude. If you will observe here, altitude lies in the internal part of this triangle. But in case of obtuse angle triangle, if a perpendicular drawn from vertex on its opposite side, so for that purpose we have to extend this base here. So means this altitude lies in the external part. Remember this one. So here this will be the height and this will be what? Base. So in some here also in some cases triangle is obtuse angle triangle. So then let us try to prove it. But before going to prove, we have to do some construction also. So observe what is our construction. So observe the construction. Here our construction is draw DM perpendicular to AE and EN is perpendicular to AD. So whatever may be our construction, just write down construction here. So our construction is draw what? DM perpendicular to AE and EN perpendicular to this. EN is perpendicular to AD. Then join BE and CD. So join BE and CD. So well, now let us try to prove this result. So we know that area of triangle will be equals to half base into height. So here we are considering four triangles. So which triangle we have to consider, that depends on our required result. First we are considering such triangle whose one side is AD. So observe this figure very carefully. AD is the side of triangle ADE. So first we are considering this triangle. Which triangle? Triangle ADE. So area of triangle ADE is equals to, area of this triangle AD is equals to, we have a formula that half into base into height. So which is equals to half into, now we are substituting the value of base. So in this case base will be equals to AD. If I am considering AD as a base, then what will be its corresponding height? Its corresponding height is EN. So into EN. So let us denote this equation say by equation number first. In this way we have got the area of first triangle. Now we are finding area of such triangle whose one of the side is what? DB. So observe the side DB. DB is the side of which triangle? DB is the side of triangle DBE. So we are considering this triangle, triangle DBE. In this triangle, again area can be found out applying the same formula, half base into height. What is the base? If we are considering DB as a base here, DB as a base, then its corresponding height. If you observe this triangle, DBE, it is obtuse angle. So it is obtuse angle, so its height is in the exterior part. And what is its corresponding height here? EN. So into EN. So this result we have got applying same formula, half base into height, denoted by equation number second. Now we are finding area of such triangle whose one side is what? AE. So observe this side AE. A is the side of which triangle? ADE. So consider this triangle ADE and try to find out its area. Area of triangle ADE is equals to, see, already we will have the area of triangle ADE, but in that case we have considered base as what? AD. So here we have considered base as AD. But here now we are considering our base as what? AE. If we are considering base as AE, so here we will get half into base. If we are considering AE as base, then what will be your height? Its corresponding height is what? DM. So into DM. Let us denote this equation say by equation number 3. Sorry, DM is there. Now consider a triangle, such triangle whose one side is what? EC. EC is the side of which triangle? EC is the side of ECD. So consider triangle ECD. In this triangle, again find out the area applying same formula. What is the formula to find out area of triangle? Half into base. If we are considering EC as base, then its corresponding height. Here also this triangle is what? Obtuse angle triangle. So its height lies in the exterior part and its corresponding height is what? DM. So DM, let us denote it by equation number 4. Now if you will observe here very carefully, if we are taking the ratio of area of first two triangles, see, observe what we will get. Half will get cancelled and EL will get cancelled. What will get? AD upon DB, and which is nothing but one side of our required result, AD upon DB. Means to get this ratio we have to take the ratio of area of these two triangles. So now we are taking ratio of area of triangle, which triangle? ADE, and area of triangle DBE. So let us see what we will get here. Now substitute the value. Already the values are known to us. Area of triangle AD is equal to half into AD into EN, and area of this triangle will be equals to half into DB into EN. So after simplifying it, let us see what we will get. Half of will get cancelled, EN will also get cancelled. What is the remaining part? AD upon DB. So AD upon DB. Let us denote this new equation say by equation number 5. Now we are finding, to get the value on this right hand side, we are taking ratio of area of these two triangles. If we are taking its ratio, half of will get cancelled, DM will get cancelled. What is the remaining part? AE upon EC. AE upon EC. So to get the right hand side of our required result, take the ratio of area of these two triangles. So area of triangle ADE and area of triangle ECD is equals to, so substitute the area of this triangle, which is nothing but half into AE into DM, and area of triangle ECD is equal to, area of triangle ECD is equal to half into EC into DM. So which is equal to check that which terms will get cancelled. Half of will get cancelled and this dm will also get cancelled. What is remaining part here? AE upon EC. AE upon EC. Let us denote this new equation say by equation number 6. Now observe our required result. What is our required result here? We have to show that these two ratios are equal. These two ratios are what? Equal. That is our required result. Now to show that this right hand side of these two equations are equal, means to show that these right hand sides are equal, we have to show that these left hand sides are also equal. Means if we are able to show that these left hand sides are equal, we can say that these right hand sides are also equal. Means to get our required result, we have to show that these left hand sides are equal. Now observe the left hand sides very carefully. Check whether the numerator of both the terms is exactly same. Yes, here also numerator is area of triangle ADE. Here also numerator is area of triangle ADE. Means what we have got here, numerators are same. Now we are trying to show that denominators are same. What is the denominator of first term? Area of triangle DBE, and here area of triangle ECD. Now observe these two triangles in this figure, DBE and ECD. This is triangle DBE and this is triangle ECD. If you observe this triangle DBE and ECD, whether these two triangles have one common side, which common side? D is the common side of both the triangle. If I am considering D as the base of this triangle, base of both the triangle, which two triangle? Triangle DBE and ECD. If I am considering they have their common base will be equals to what? DE. Then check whether these two triangles lie between two parallel lines. Yes, these two triangles lie between two parallel lines. And one of the theorem which you have proved in 9th standard says that if two triangles have same base and lies between two parallels, at that time their area will be what? Equal. So these two triangle which triangle? DBE, triangle DBE and triangle ECD have same base DE and they lies between two parallel. That's why we can say that their areas are what? Equal. So here we can say that area of triangle, which triangle? DBE is equals to area of triangle, which triangle? ECD. These two areas are equal. Area of triangle DBE and area of triangle ECD are equal. What is the reason? That these two triangles have same base. Same base we are denoted by what? DE. So give the reason here. Triangle having same base. Same base we are denoted by what? DE. Triangle having same base DE and lies between two parallels. Which two parallels? DE and what? BC. Lies between two parallels DE and BC. And our theorem says that if two triangles have what? Same base and lies between two parallel, at that time their areas are equal. So area of these two triangles are equal since they have same base and they lies between two parallel. Denote this by next equation, equation number what? 7. Now from equation number 7 we have shown that what? This area of these both the triangles are same. Means now values in the numerators are also equal and area of triangle in the denominators are also equal. Means we can say that these ratios are equal. If these ratios are equal, then what is your conclusion here? Means if left hand sides are equal, then right hand sides are also what? Equal. So from equation 5, 6 and 7, what is your conclusion here? AD upon DB is equals to AE upon EC. Okay. So in this way we have proved that if a line is drawn parallel to one side of a triangle, then it divides other two sides in equal ratio. See, in this theorem lot of construction is there, so make the proper utilize of this equation to get the result. अगर आपको एक बार में समझ में नहीं आ रहा है तो आप उसे फिर से 2-3 बार देख लीजिए. You will come to know that what are the steps here and easily you are able to understand this proof. Now we are going to prove converse of basic proportionality theorem. So now observe the statement of converse of basic proportionality theorem. So in this case, a line divides any two sides of a triangle in same ratio. Then we have to prove that the line is parallel to the third side. So what is BPT? A line is parallel to the third side. Then it divide. A line is parallel to what? Third side. Then it divide other two side in equal ratio. Now here in the BPT, line is parallel. Then we have shown that ratios are equal. In this case, ratios are equal, then we have to prove that line is what? Parallel. So that's why it is called as what? Converse of BPT. So first write down the given condition in this triangle ABC. So line DE intersect two sides AB and what? AC. Intersect sides AB and AC. At which points? At points D and E respectively. At point D and E respectively, such that, so this line is drawn such that these ratios are equal. Which ratios are equal? That AD upon DB is equals to AE upon EC. AE upon EC. So that the line divides two sides of a triangle in what? Same ratio. If a line divides in same ratio, then we have to prove that that line is parallel to our third side. So we have to prove that this line D is parallel to third side. So means what we have to prove here? So to prove that line D is parallel to BC. Line DE is parallel to which side? BC. So well, this is our required result. To prove this, now we are using contradiction method. So if possible, suppose that line D is not parallel to BC. So we have to prove that D is parallel to BC, but we are supposing that D is not parallel to BC. So let us try to prove it using contradiction method. So if possible, suppose that line DE is not parallel to side BC. If we are supposing that D is not parallel to BC, means suppose that one triangle is there, and if this line is not parallel to this side, means definitely there exists one line which is parallel to this side and passes through this point. Definitely there exists what? One line which is parallel to this side. Now what is our supposition? D is not parallel. D is not parallel to BC. Means definitely there exists another line which is parallel to BC. So I am supposing that. So let us suppose that line DE dash is parallel to what? BC. So we are supposing that. So D is not parallel to BC. So let there exist line DE dash parallel to BC. And if this line DE dash is parallel to BC, then our last theorem says that, basic proportionality theorem says that, so by BPT, what is that basic proportionality theorem? If a line is drawn parallel to one side of a triangle, then it divides other two sides in what? Equal ratio. Means which two ratios are equal? AD upon DB will be equals to AE dash upon E dash C. AE dash upon E dash C. These ratios are equal. This result we have got from the last theorem, basic proportionality theorem, because line DE dash is parallel to BC, means it divides other two sides in equal ratio. Now this is the given condition. Let us denote this given condition, say by equation number second, and the result which you have got from basic proportionality theorem, we are denoting it by equation number 2. If you will observe these two equations very carefully, check whether their left hand sides are equal, AD upon DB, and here also left hand side is what? AD upon DB. If left hand sides are equal, then we can say that right hand sides are also equal. Means what result we will get from equation first and second? From equation first and second, we can say that AE upon EC will be equals to AE dash upon E dash C. Since the left hand sides are equal, that's why we can say that these right hand sides are also equal. Now we have got this result. Just simply we are adding 1 on both sides. Let us see what we will get if we are adding 1 on both sides. AE upon EC plus 1 is equals to AE dash upon E dash C plus 1. Simply we are adding 1 on both sides. Now we are simplifying this expression. Just simply take the cross multiplication on both sides. So what we will get here? AE, EC into 1 will be EC. Means if you are taking cross multiplication here, we will get AE plus EC upon EC. And on this side, take the cross multiplication AE dash plus E dash C. E dash plus E dash C upon E dash C. So this result we have got just simply taking cross multiplication on both sides. So now observe the numerator. What is the addition of these two segments? AE plus EC. AE plus EC will be equals to AC. So here this numerator will be equals to AC. In the denominator EC, keep it as it is. Here also in the denominator E dash C, keep it as it is. E dash C, keep it as it is. Check what is the addition of the numerator. What is numerator? AE dash plus E dash C will be equals to what? AC. So here also in the numerator what we are getting? AC. Now if you will observe both the sides very carefully, check whether both the ratios are equal. Yes, both the ratios are equal. And even the numerators are also what? Equal. If numerators are equal, if numerator of both the ratios are equal, then what is your conclusion? Denominators are also what? Equal. These two ratios are equal. Then if numerators are also equal, then we can say that denominators are also equal. This implies that EC will be equals to E dash C. Otherwise you can say that cancelling AC on both sides, then taking reciprocal on both sides, we will get this result. But not necessary to extend the steps here. So directly we can conclude that these two ratios are equal. Their numerators are equal, means we can say that denominators are also equal. Now observe this these two sides very carefully. From the first side, what is the left hand side? EC, and second side is what? E dash C. EC means what? EC is nothing but distance between which two points? E and C. So whatever may be the distance of point E from C will be equals to distance of what? E dash from C. Means this distance EC will be equals to CE dash, means distance of point E from C will be equals to distance of point E dash from C, and both the point lies on what? Same segment. And what this statement says, that this EC and E dash C are equal, means distance of point E and E dash from point C is what? Equal. Then what is our conclusion? अगर E पॉइंट का और E डैश का डिस्टेंस C पॉइंट से एग्जैक्टली सेम है, बोले तो ये दोनों पॉइंट क्या होने चाहिए? वन एंड द सेम होने चाहिए. मींस these two points are what? Coincident point. So this implies that points, which points E and E dash coincides. And if these two points coincides each other, then that's why we can say that अगर E और E dash एक ही point है, then DE and DE dash also what? Coincides. So therefore DE and DE dash are also coincides. But what result we have got from the but according to our supposition, what is our supposition? DE dash is parallel to BC. So but DE dash is parallel to what? BC. DE dash is parallel to BC. DE dash is parallel to BC, but DE dash and DE is what? One and the same segment, coincides each other. So this implies that DE is parallel to BC. You are getting it? This segment and this segment coincides each other, means one and the same segment. So if D is parallel, D dash is parallel to BC, means we can conclude that D is also parallel to BC. In this way, we have proved two important theorems. What is first theorem? Basic proportionality theorem. Basic proportionality theorem says that if a line is parallel to one side of a triangle, then it divides other two sides in equal ratio. And converse of basic proportionality theorem says that if these ratios are equal, if the line divides two sides of a triangle in equal ratio, then that line is what? Parallel to third side. So in this way, we have proved two important theorems, and using two important theorems, we have to solve the example from next exercise. So in the next video, we will solve the example from second exercise. Well